So g'day, I'm Scott Poynton and welcome to a video about the beauty of biochar. And I'm standing in a field here in northern Ghana, where a research trial, in fact, where we're working to understand how great biochar can be to support smallholder farmers, increase their yields, improve their livelihoods, and be more resilient in the face of climate change. I'm not out here alone. I've got young Kyle Houston here with me. How are you, Kyle?
Very well, thanks. Nice to be here.
Yeah, good. Now, Kyle, you're in charge of our biochar project down here. Just tell us what the heck is biochar?
But, well, conveniently, I actually
He's got some here
on hand.
Oh, there it is.
But effectively, it's like charcoal. So charcoal is a form of biochar. You can basically make it with any kind of woody material, organic materials. It could be waste of agriculture, peanut shells, or you could also make it out of wood, as they traditionally do with charcoal. But effectively, it's very porous, so it has a lot of holes in it, which means it acts like a sponge when you put it into the soil. So it's great for holding water, and if you mix it with manure or compost, for example, it can hold a lot of nutrients as well.
It's just a giant sponge that absorbs water. And why is that important out here? I mean, we were out here the other day and it was pouring rain. Why is that a problem here?
Yeah, so as you can see, maybe I can get a little sample.
Yeah.
So the soil here, it's super gravelly and porous as well. So when it rains, the water just runs straight through and very little of that water is actually retained. So right now, as you said, we're in the wet season, but in a couple of months that will drop off and there'll be 6 months of no rain at all.
Baking temperatures.
So it's very important to have something that can retain some of that moisture. So that's effectively what the biochar does here.
This giant sponge.
Yep.
And so, just about the soils here where we are, I mean, they grow a lot of food up here, but the soil is traditionally very low in nitrogen, very low in phosphorus, and these are pretty important for plant growth. And so to combat that over decades, since really, I guess the start after World War II, when we discovered chemical fertilisers that could be made out of fossil fuels, that vast amounts of this chemical fertiliser have gone into the soils here, and it did have an increase in the yields, but the trouble is after a period of time it sort of just kills everything that's in the soils, and there's no life in the soils. And we often forget about this one, but another benefit of biochar is because it's this giant sponge with lots of water in it, all the little microbes and things and bacteria can find their way into those pores and live there. So biochar helps bring life back to the soil as well, right? So it's an amazing little substance that holds water like a sponge, holds nutrients, and allows life to come back into the soil. And why is that important? Is because the plant roots, can interact with the soil microbiome, we call it, which is all the fungi, the bacteria, and helps them get access to the limited nutrients that are here in these soils. So that's why for us, we're excited about biochar. Last year, this before Kyle came down, last year we tested it. The farmers didn't know about biochar here, Kyle. Tell us quickly about the history, if you like, of biochar. It really is this new, ancient discovery, right?
So yeah, exactly. As you mentioned, a lot of the farmers here are not familiar with biochar, but it's not a new technology. So they found, for example, in the Amazon, soil pits where the indigenous people have been using biochar for thousands of years. But due to, I guess, technologies being lost and the implementation of fertilizers and modern day pesticides and herbicides, it's sort of been forgotten. So that's why this new it's coming back into rediscovery, but really it's an old technology that is just coming back. And
the farmers do it when they make charcoal. We go through the communities here and the farmers are making charcoal for their cooking. It's the same process. It's basically you're cooking up agricultural waste instead of wood at high temperatures and low oxygen. And that's how you make charcoal. It's how you make biochar. You basically can put it in a soil pit, you can put it in a drum, get a roaring fire going, have some oxygen in there, put a lid on it, quieten it down, and gradually all of the chemicals, all of the water, everything sort of just gases off, and you're left with this carbon structure which makes all those holes that Kyle was talking about. So we came here last year and said to the farmers, there's all this agricultural waste lying around. I'm like, why don't we make some biochar out of that? And they, what do you mean? What's biochar? And it's not because they're stupid. It's just because for generations they've been told you've got to put chemicals on from the fossil fuel industry. And we're like, no. And of course, last year in particular with the Ukraine war, the price of fossil fuels went through the roof. They couldn't afford it. And this really impacts their yields because the soils here are so heavily degraded by generations of fossil fuel use, that they couldn't afford it. So we said, well, look at all those peanut shells that you got there, let's make some biochar. So we worked with them, we made some biochar with the farmers, we popped it on our demonstration fields. At the end of the season, 3 months later, when we harvested the Bambara crop, we had 26% yield increase on average just by putting biochar. Some fields we had up to 40% yield increases. Farmers couldn't believe it. And so this year we've gone a bit further. We've actually got this big research trial that we've planted here with various biochar treatments, and we're going to try, how much do we put on? Can we mix it with, as you said, Kyle, manure, compost, biostimulants? What impact does that have? So our idea is to learn here the best way to use biochar, and then we can take that knowledge out and share it with our partner farmers so they can increase their yields, maybe even by more than 40%, right? So it's pretty exciting. These are some of the poorest farmers anywhere in the world. They are suffering the impact of climate change, and if we can help make their crops more resilient and their lives more resilient in the face of climate change, then that's a good thing. And the secret could be in the handful of this amazing little black substance that the farmers can make themselves, called biochar. Thank you.